3, 2, 1.
Here we go!
All right. Well, good morning, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. It is World Ocean Week, and we're celebrating the way we always do in June by hosting way too many events crammed into one week. But they're spilling over into next week as well. There's tons of ocean action, and we wouldn't have it any other way. We'd love to do a ton of live ocean events to wrap up the school year. We've got ocean scientists, explorers, researchers, conservationists joining us to share their stories, their adventures, what they're finding, how they're protecting our ocean, and then how they're bringing those stories and findings to classes and the general public through different media around the world. So if you visit exploringbytheseat.com, you can see we still have a ton of events coming up this week, and then even more events spilling over into next week. So we hope to see you in some more ocean action with us. Let's see, a few more events coming your way today. You can see them on the schedule, including sharks this afternoon at 2 o'clock. We'll be talking about sharks in the area in Colombia around Mapello, which is a protected area. So do join us for that if you can. Today, we're going to spend a little time with one of my friends who I've had the pleasure of being on an ocean vessel with in the past, Jessica Sandoval. She is an engineer and ocean explorer. She's a seasoned ROV pilot with over 10 years experience operating deep sea submersibles. So you might know them as ROVs or remotely operated vehicles. She can be out for weeks at sea, exploring the deep ocean, places nobody has ever seen before, which is a pretty cool kind of exploration. When she's not on the water, she's the founder of her own company, Aquavella, where she works to develop engineering solutions for the ocean. So I'm going to grab Jessica right now. Here we go. Hey, Jessica, how are you?
Hello, I'm good. How are you guys doing?
Good, good. It's so great to have you with us. Initially, we're going to be from an expedition ship, but we're going to teach students about expeditions right now. They don't always go as planned. So I know your start date has been pushed off by about another week, I think, 6 or 7 days you'll be on board the ship.
Yep. In 6 days I'll be flying, and in 7 days I'll be on a ship. So
All right. Excellent. Well, we still love to steal you because you have pictures and stories and video clips, and you were just in Antarctica, which is, well, that makes me very jealous.
yeah, it was 2.5 months there, so it was a good time, all on a ship. So you'd expect the seas to be crazy, but it was actually really awesome sailing.
All right. Well, let's get into it. Jess, if you want to share your screen, I'll give a shout out to our classrooms. I see Dalewood Middle School saying hi in Hamilton, Ontario. I see some grade 5s in Edmonton, Alberta saying hi as well. Use that chat. Don't be shy. Send us in some questions. And then we'll have a Kahoot as well while Jess is presenting. I'm going to make a Kahoot quiz and we'll test our new ocean knowledge. Yeah, that's the plan.
Lovely. All right, we'll get this show on the road. Can you see my slides all right?
I see it loading. If you want to hit the hide on this, perfect. We're ready, Jess.
Okay, perfect. All right, well, hello everyone. Happy Oceans Week. Today we are going to be taking a deep dive into the deep sea. So that's, as Joe mentioned, that's my area of fascination and also my area of expertise, and just the thing that I love the most. So let's hop in, because oceans are so vast. We have so little time to talk about such a vast topic. But my name is Jess. I am an ROV pilot. So this is what a day in the life at sea looks like for me. You get kind of your hands dirty, you get all full of water, and I wouldn't have it any other way. It's just a really engaging environment to feel very alive and in tune with the ocean. So, as we mentioned, I'm a pilot, so we'll talk a lot about what's underwater and how we get there with vehicles. So I've been doing that for about 10 years now, started in 2015. Time has somehow flown by. Um, but I'm also a fun sock wearer. So at sea, I always like to wear a fun pair of socks that represents what I'm feeling that day. Usually it's a donut sock or some jellyfish socks. You can have fun with it out there. I'm also a doctor, so I have a doctorate in engineering and my own company as well. So I love engineering. I'm a big engineering nerd, as my friends call me. And but most important out of all of this is that I'm also a kid at heart. And that's the really fantastic thing about working at sea and working with the ocean is that you're constantly curious and you're constantly asking questions. So I'd say of all of these photos here and of all of these hats that I'm wearing, I think kid at heart is the most important hat to wear. But as we mentioned, today is about talking about Antarctica. And so I was down there from December to February. And so that was about 2.5 months or so in total. And I was out there with the Schmidt Ocean Institute. And what that looks like is that from this map here, you have the very southern tip of Chile, so South America, flew into Punta Arenas and did actually 2 back-to-back expeditions here that we'll be talking about. The first one, you have the Antarctic Peninsula on the bottom of the screen. We went to the eastern side of the peninsula, spent about a month out there. And then after that, we did a much longer trip, which is about 10 days of just transit time. So we're transiting on the ship 10 days down to this kind of armpit, if you will, of the peninsula on the western side. And we stayed there for about 6 weeks or so. So there's a lot to do and a lot going on out in Antarctica. As you can see in this picture, there's glaciers for days and there's icebergs for days. And actually, the place that we went on this kind of the armpit that I was talking about before on the western side, actually a piece of the ice shelf broke off, made this massive iceberg, and when we surveyed there for the first time. So this is kind of the day in the office for me. This is an exceptional day in the office because I don't usually see icebergs. Sometimes it's more tropical, but this time it was much icier. So we had some exciting excursions around Antarctica. There's the actual continent there in the photo, and you had to be bundled up in so many bundles so you're not getting frostbite. And we always had some onlookers of penguins that were always curious as to what we were doing. But the whole reason why we were there is the ocean. We're looking at diving deep into the waters surrounding Antarctica. And so this is what the ocean looks like. Most of the ocean is actually incredibly, incredibly dark. So when we think of if we think of the Earth, we think blue, right? Ocean is predominantly blue when we look at maps, but actually the ocean is black. It's dark and we can't see in it. But it's also deep. Most of the ocean is actually 3,000, on average, about 3,000 meters in depth, which is about, take a 1,000-story building and submerge it in the ocean. That's about as deep as the average depth of the ocean, not the deepest point. It's also incredibly heavy, so there's a lot of pressure that we'll talk about, and it's cold. So it's not maybe a place that humans thrive, but a lot of life thrives in the ocean. So the question that we had going into this Antarctic expedition is what could possibly live in these waters outside of or surrounding Antarctica, surrounding these ice shelves? And it turns out a whole lot. So all these photos that I'll show right now are from this Antarctica expedition. And a lot of this is looking at life underneath what this ice shelf is. So there's a whole bunch of ice that's usually covering these ecosystems. And these are growing in the dark, these are growing in the cold, and these are growing under incredible pressure. So some of my favorites are some highlights for myself. One of them is something called a flying spaghetti monster, which is actually a siphonophore. And believe it or not, this thing is actually an animal, and it's actually a colony of animals growing together. So It doesn't look maybe like a human, but this is certainly an animal, and it's certainly thriving in these depths. They're walls of sponges and corals. So sponges down there are not like the sponges we use in our kitchen. These are actually made out of glass. So these are, think of like fiberglass. It's kind of sticky and sticks in your hand. So these are glass sponges, and they grow incredibly slow. You also see in this picture some corals, a lot of just life filling the walls down there. Um, some of my favorite images, though, are of phantom jellies. So I called them phantoms. So when I called home, I said, I saw phantoms in the ocean. So they're phantom jellies, and these can reach about 30 feet long, so about 10 meters, which is also incredibly long. We had some staring contests with crabs. There's abundance of crab down there, some of which are quite spiky, and you know they're good at staring if you think about it. We'd zoom in on them and they never blinked. There's also jelly life that looks incredibly crazy, a little bit extraterrestrial, if you will, um, but really incredible jelly life down there too. We of course saw octopus, and this one's being a little shy, but octopus are also really commonly found in the deep ocean, and they're always such a delight to encounter. But this one is indeed a little bit shyer. Um, and I love this image of these sponges. So this is another glass sponge. But glass sponges grow so slowly in the cold and under these pressures. They grow incredibly slowly. These are actually animals. They're filtering out the water. And they're eating the small things that are in the water column. But the coolest thing about glass sponges is that this sponge here, for instance, would probably be thousands of years old. So they grow so slowly, but that also means they're kind of like ancient creatures on our planet. So some of the oldest creatures on our planet are actually glass sponges. So those are some cool images of what we saw. But also what I'm here to talk about is how do we get to the deep sea? As a pilot and as an engineer, we get to the deep ocean with technology. And one of the things that we have to engineer against, though, is pressure. So, as I said before, the ocean is really heavy. And what that means is that the water is constantly pushing from all over on whatever we're putting in the water. And it just compounds and compounds itself as we go deeper and deeper. And we're going down thousands of meters. So, this is just an example here of a styrofoam cup, and it has a bunch of air in it. And then this on the right-hand side of the image is actually what the styrofoam cup looks like when we take it back from the water. And you can see that as it's diving deeper, it's squishing this cup all from equal sides and making a small little miniature teacup, if you will. So this is what we're up against when we're thinking about putting technology in the water, is the technology is constantly getting squished. Um, For this reason, we use robots a lot of the time. We use ROVs, remotely operated vehicles, and these are the things that I pilot. And so these are giant robots that are engineered to withstand all these incredible pressures, the cold, the saltiness of the water, and also just the darkness of the deep ocean. So I wanted to talk a little bit about what I see in an ROV and what's actually going on one of these robots, because that's just as cool to me as what's going on the seafloor, if you can believe that. So that means I'm a big engineering nerd, as I said before. But what's going on these vehicles? There's a lot. So we are usually in exploration mode. So we have these maps of the sea floor that we're constantly using to help us explore. And we're really there to see the unseen, because most of this has never been seen before by humans and never will be seen again, because the likelihood of going back to that spot is incredibly small. So to get pictures like this of these beautiful glass sponges, we have a lot of things going on at the same time. We have at the center of the screen here the HD camera, the center of the vehicle. And the camera is taking these beautiful high resolution shots. And we're flying around this camera, acting kind of like a cinematic eyeball, if you will. We're also in a place that's incredibly dark. And so we need to put lighting everywhere. So for all these shots, all the light comes from our vehicles. Otherwise, all these organisms, all these animals are living in complete darkness. So we have to flood the area with light to get any images. We also have a bunch of situational cameras. So these are the ones that we use as pilots in order to see where we're going, so we're not bumping into things, and also to be aware of our surroundings in a way that we can manipulate or maneuver responsibly. We also use sonar. So because the seafloor is dark, we use sonar, which is acoustics, in order to quote unquote see, but we're actually seeing with sound. And so this helps us to see what's further along in the horizon, if you will, for about maybe 80 meters, maybe 100 meters. We have a really good sonar. So we can see a lot further ahead. We can see walls coming up so we can approach them with caution and responsibly. And we also have a whole bunch of other sensors. So I don't have picture of those sensors, but we're always taking samples of the oxygen in the water, of the conductivity, basically the amount of diluted salts in the water. But the second thing that we're doing too is that we're taking samples. And so sample collection is also very critical and vital to us, to scientists, to geologists, biologists. And we take samples with these things called manipulators. So these are robotic arms. They're quite tall, so they're taller than me if they were to stand up straight. And we use something like a controller in the control van. So this is an example of a controller that we use. And so every small movement that we make on this controller corresponds to the same exact movement of these robotic manipulators underwater. And what that means is that we can make really precise movements with the manipulators in order to take samples of these really delicate specimens. We also take push cores. So this is taking samples of the sediment or mud. It's another way to think about it. Taking samples of what's on the seafloor, what lives in this mud actually is a lot as well. There's a lot of worms that live in the mud, just like here up on the land. But there's a whole ecosystem that lives in the mud too, that has a really incredible job of incorporating the carbon that's in the water and the whole process and ecosystem there too. That's vital to what we do here on land. There's also bio boxes. So we put these kind of open up. Well, that's how they open up. They do a little wave. But we put rock samples in these. We put animal samples, like little small snippets, in order for scientists to study these in the future. There's also a suction sampler, and this is by far one of my favorite things to use to sample. And it uses suction. It kind of makes a little slurp, and you can grab most delicate samples using a suction sampler. And so this is an example here of just a very delicate sample that we suction sampled. So we slurped it out of the water column. And these are actually kind of floating and they swim really elegantly. These are called crinoids. And they'll just, they're very hard and elusive to capture. But these will be useful for scientists, again, studying the biology down here. And then we take water samples. So this is useful for people that study, whether it's physical oceanography, also biological oceanography. People that study microplastics are really usually interested in water samples as well. And then to get this whole entire vehicle out to sea, get it in the water, it really takes a team. So I'm one pilot, but there's usually a team of about 8 out there. So we have 8 pilots, and we're constantly rotating over. And so this is what a deployment looks like for us. We have some team, and we have some heavy machinery to help get these vehicles over the side of the ship. And that's really important because with this machinery and with this team, we can take a vehicle that's on our ship and send it down to 4,500 meters depth. And it's kind of this beautiful dance and orchestration that's very precise and very well organized. And if you can imagine this vehicle that's 3,000 kilograms in air is actually kind of floaty. We call it positive in water. And it's because it's heavy, but it has a lot of syntactic foam on it and it's able to almost float in the water. And this allows us to really get some amazing footage as well, in addition to operate safely. And just because this is usually a question that I get a lot is how fast can we talk to this robot? And it's actually at the speed of light. So we're communicating with it with something called fiber optics. And so it's something that's like the size of a strand of hair, a few strands of hair, but it communicates at the speed of light. And so we can talk to our robot that's on the sea floor, thousands of meters below, and we can make these instant communications. So that's kind of the operation side. But just to add some light and levity too, our ROV piloting also inspires a lot of creativity. So there's artists at sea, and I also like to dabble in art, I suppose. And so I like to write poems and journal when I'm at sea. And this is what I do in my pastime, my fun time. And so I'll make these poems and sketches. And one of the things I was quite excited to do is put out all my poems and illustrations. And so this was published by the Ocean Exploration Trust in 2021, and it's a freely available resource. So if you're ever interested in some funny deep sea poetry, I suggest to, give it a check out, and it gives you a different lens into deep sea exploration as well. So in the end, we communicate the deep sea exploration, we explore just because most of the ocean is actually unseen by humans. And this is very, very important because most of our planet is ocean. And so this means that most of our planet is still unknown to humans, which is awesome for us because we're incredibly curious. And that also means there's so much space to still explore, so much space for you to get involved in the next coming years as well. So really my question to you is, what will you discover in the next 10, 20, 30 years? Because really we still have so much to know about our oceans and of our own planet. So with that, I'll just say that's just the start, the tip of the iceberg, if you will, since we're talking about Antarctica. And thank you for listening. And a shout out to the Chaunacops because it's just one of the coolest sea creatures as well, in my opinion.
All right, fair enough. Jess, thank you so much for that great presentation. Yeah, I mean, from my experience, it's a lot of fun being on an ocean research vessel. You get to meet great people. You get to see things nobody's ever seen before. The food was pretty good. You get to play with machines. It's a pretty good way to spend a month or two.
Yeah, exactly. Foods always taste, and you never have to cook out there. They're always fantastic meals.
That's a big plus.
24/7.
That is a big plus. All right. Well, before we get into some Q&A action, if you do have questions, you can start to put them into the chat for us, and we'll get those questions to Jess. But I'm going to share my screen. We're going to play a little Kahoot. So you should see it coming up shortly. There we go. I'm going to hit start. There are a few ways you could join us if you want to play along today. You can visit kahoot.it and put in this PIN number, 22226. If you have one, you've got a Chromebook, maybe you have a tablet, you could join that way. If you're not able to join like that, your teacher could pop it up at the front of the classroom. You could shout out your answers to him or her. If you are tuning in from home, that QR code at the top works great on your phone or your tablet. You can join that way. And you know what? Sometimes you don't always have access to technology. You can just play along and see how you do. You don't have to join with tech. You can still test your deep sea ROV knowledge. Jess, while we're waiting for a few groups to join us, let's do a couple of quick questions. And I think I'm going to start with one that you and I were just talking about is you're always on the move as an ROV pilot. You're in demand. So where are you heading next?
Oh yeah, definitely. We're always traveling around, and so I'm going next in about 6 days back to Chile. So I'll be flying into Concepcion, and I'll be in Chile for the first expedition. Then after that, I'll be in not Antarctica. We just went there, Argentina, and then after that will be Uruguay for me.
All right, sounds pretty cool. We know all about gear, right? There's important gear for the ROVs, but what about for you personally? What's something you always want to make sure you have with you when you head out on one of these expeditions?
Oh yeah. Okay. Well, there's a few. I have a checklist actually.
Okay.
I always have a blank journal because I love writing about what we're seeing. Otherwise, you might forget out of all the cool things you see. I always bring chocolate because that keeps me awake, and usually some type of jerky as well. Speaking of food, and then I also always have some gloves on me too because usually it's kind of cold at sea, and steel-toed boots. So you always have to have steel toes in my line of work. Protects your toes from getting squished, and so those are kind of the critical ones that I take out with me.
All right, excellent. Well, I think we should play some Kahoot because I want to get into the Q&A action. Looks like we've got some groups in here with us, so I think we are ready to go. I'm going to hit start. It's going to count you in. There's some true or false, some multiple choice. The quicker you get that right answer in, the more points you are going to get. And I've started us off with a nice, easy warm-up question. So we're going to get counted in, and then we are going to be off to the races. So first question is a multiple choice. Jess's last expedition was in the Arctic, the Galapagos, Antarctica, or Fiji. I even put a clue in here to decode, which should help you eliminate some of them. But we've mentioned it quite a few times, so I think this will be a nice warm-up question for us, and then we will go from there. Jess, while this is counting down, are you with the same group? I think it looked like you were with Schmidt Ocean Institute last time, or are you with a different group?
Yeah. So I contract around to different groups, and so last time I was with Schmidt, and this next time I'll also be going out with Schmidt as well.
All right.
But actually, Joe and I met on a different ship called EB Nautilus. So you can move around to different expedition vessels or exploration vessels or research vessels.
Yep. All right. So Antarctica, looks like most of our crew went with Antarctica. A few saw the icy picture and chose Arctic, but it is Antarctica. Let's go to our leaderboard. The excited Bobcat holding down that top spot. We've got to go to another question, multiple choice. Which word doesn't belong to describe most of the ocean? So I've got 4 words down here: cold, dark, deep, and bright. One of those is not a good descriptor for most of the ocean on our planet. Is it cold, dark, deep, or bright? Which one should we get rid of to help us more accurately describe most of the ocean? You've got about 10 more seconds to get something locked in. And then we'll take another look at our leaderboard. Okay, that was a nice one for our classrooms. They all wiped out bright. Definitely there's lots of parts where it's bright and beautiful, especially on those coral reefs. But as you get deeper, which most of the ocean is, cold, deep, dark, heavy, those are better words to describe the ocean.
Ooh, I love it. I love that everyone got that one right. Amazing.
All right, excited Bobcat, not letting go. Glass sponges are not animals. Is that true or false? Look at that picture. Maybe that will help you, or maybe that will not help you. Glass sponges are not animals. True or false? Got about 5 seconds. 5 seconds to lock something in. There we go. Most went with false, and that is right. They're animals. They're weird animals without mouths and eyes and things that we typically think of when we think about most animals, but they are animals. Very cool. And some of the oldest living on our planet. So that's pretty awesome too. Let's see. I think excited Bobcat might go all the way, but Annual Impala is less than 100 away. So if they're fast, they could pull it off. Here we go. Multiple choice coming your way. How can Jess take samples from the deep? With suction, with push cores, with manipulator arms, or all of the above? So we've got those ROVs. They're expensive, they're heavy, they're fancy. How can Jess take some samples from the deep? With suction, with push cores, with manipulator arms, or all of the above? Sometimes it pays to take a split second to see the options, because I know we might get a couple classrooms on this one. We'll see. Suction, push cores, manipulator arms, or all of the above?
Wow.
There we go. Most went all of the above. One went suction, and I think it might just be wanting to get that answer in so fast. I understand that for sure. In third place, we've got the Prairie Glider.
Ooh, very nice. Very nice.
Second place, the Amiable Impala. And let's see, will there be a Bobcat on top or somebody else? Nope, we did not fool the excited Bobcat. All right, good job, students. Good job, classrooms. Thank you for playing along. I'm going to come back from that screen share. Let's fill up that chat with some more questions for Jess. I'm sure there's questions about ocean exploration, Antarctica, what she sees in the deep, those super cool ROVs. And we'll start off with a question about those super cool ROVs. How hard are they to pilot?
Oh, how hard are they to pilot? It's a double-edged question, this one, because if you say they're easy to pilot, you don't have a job, and if you say they're hard to pilot, you don't have a job.
Right.
No, it's definitely a balance. I would say learning how to pilot an ROV, you're constantly learning, actually, even after 10 years. But definitely the startup time is, you have mentors and you learn on the job. And so it becomes a lot easier, but you're always trying to perfect it. You're always trying to have these really cool shots you're trying to get. If you don't get it the first time, you'll get it the second time. So I'm also still always kind of finessing the skills, if you will. And that's also what makes me always engaged and excited about my job, is that I'm still kind of learning always.
Yeah, and I'm always interested to look at the controls. They do, in some ways, look similar to like a video game with a joystick, maybe a few buttons. I've seen submersibles where people actually get into where they are actually holding what looks like a video game joystick. So, those video game skills could potentially help you in a future ROV career. And so this brings us to a question from Edmonton, Alberta. And they're wondering, there's obviously you as the pilot, but how big is the team that it takes to make, all those functions with the ROV run?
Yeah. So the ROV team, we're about 8 people strong. But it's more than the ROV team, actually. It's the whole ship. So we are always in constant correspondence with the bridge. So this is the captain. These are the mates. These are the people driving the boat. And we're also constantly in communication with the science communicators out there, with any navigators as well, depending on the setup of the ship. Some ships have navigators designated. Some ships, it's more marine technicians. So there's a whole orchestra of folks. And then there's also the deck team that's helping us to get this over the side. I would say it takes the whole ship. And, ships can be 40 people large. It can be 50 people large. It can be 30 people. So it really depends on the crew, but it takes a whole team.
Yeah. I remember being in the van on Nautilus, the control van, and I believe there were 2 pilots on the go. There was a navigator next to you guys. There were video people who were taking stills and pulling clips. We had a team of scientists sitting in the back who could talk about what we were seeing and tell you guys, whoa, go back, grab that, check that thing out.
Right.
So yeah, it's definitely it's a happening place when the team's on and the ROV's in the water.
Yeah. It's a dance of all. Yeah, for sure.
Yeah, good stuff. Okay. So it looked like from the pictures that you have to get your hands dirty with the ROV. So this group is wondering what kind of things can go wrong.
Oh, yeah. Okay, cool. There's always things that could potentially not be good. But yeah, we're always constantly maintaining the system so that we're mitigating or kind of reducing the chances of something going wrong. So as you see in the pictures where we're getting our hands dirty, we do kind of routine checks and maintenance. So we're, making sure that everything's watertight so no water gets in. We're using a lot of things that are also eco-friendly, so like mineral oils. So our junction boxes are J boxes, kind of these electronics boxes. We have instruments that we add for science party, and so if they want to add on a certain sensor, we'll put those on. We'll integrate them in. But everything is actually constantly being checked because we don't want something to go wrong. Because if something does go wrong deep sea, it could be not not good for these multi-million-dollar vehicles. So we're constantly doing routine maintenance, and so we're constantly getting our hands in the mix of things within the guts of the system, if you will. Um, yeah, so other things that can go wrong, it could be something really minor that's easily fixable. And if it's something that's kind of show stopping, that's what we're trying to mitigate against because we don't want scientists to lose really precious sea time because some scientists will wait years in order to get out onto a ship. So any downtime that we have is kind of a lost opportunity for science.
Yeah. Yeah, absolutely. I definitely remember you and the team doing all kinds of stuff. Whether it was making repairs, whether it was I have a distinct memory of you making some cuts on the metal, so there were sparks flying. There was action happening. You definitely were busy when the ROV made it onto the deck. The work just continued. So,
hmm
yeah,
And sometimes we're also like jerry rigging. Well, jerry rigging's not the right word here, but we
no,
were essentially MacGyvering some solutions to like mounting brackets and all too, right? We're always constantly making small, what we call ROV innovations. It can be a sampler that's actually a milk jug that we're cutting up into bits and adding on. We have a toilet brush of science is a really fun one. It's basically a toilet brush that we use for cleaning off deep sea cameras, if you can believe it. Um, so we're always playing around with how to mount things better, how to mount things for science. Yeah, so it's always constantly entertaining for sure.
fair enough. You've got $1 million pieces of equipment, but the toilet brush saves the day and gets the HD camera clean.
Exactly.
Yeah, cool. Okay, so we've got a group here in Florida, and they're wondering, did the marine life pay attention to the ROV? Do they find it interesting?
Oh yeah, we definitely get some curious creatures down there. So you get a whole range of things, and there's definitely curiosity, especially among fish. They'll kind of like wander their way over. Sharks are actually a lot shyer, so they will shy away from the vehicle. So you'll usually get a few images of them, but they'll usually want to be left alone. Octopus, it really depends, honestly, but there is definitely a lot of curious creatures down there. And if you think about it, the ROV is a ball of light that we're sending down, and these places are generally pitch black. And so they're just as curious about us as we are about them because we're this bright thing that they've never seen before and they probably will never see again. So, yeah, there's definitely some curious creatures.
All right. Same group is wondering about, do you ever see like human impact on the deep sea?
Yeah. So it depends on where we're working, but some places you'll see fishing nets, and those are just as much of a hazard for the marine life as it is for an ROV. Because we don't want to get entangled. So I've seen fishing nets a bit, especially along coastal areas, so where there's more fishing activity. Sometimes, unfortunately, even if we're in the middle of like the South Pacific, say, we'll still see some plastic on the seafloor. So I know marine plastic, or sorry, yeah, plastic pollution is really hot right now, and so we do see yeah, one time I saw a chair like sitting upright on the seafloor, and I was like, that is the eeriest thing to see. You're in the middle of nowhere, but you still see a chair, and it's perched perfectly upright. Yeah, so we do see human impacts for sure, plastics. Um, Thankfully, there's new innovations happening, more awareness about what's happening in our oceans. Um, But yeah, there's still a lot of human impact down there.
Yeah, one that always stuck with me on the first dive, a spot probably nobody in the world had ever seen before, and there was a Dr. Pepper can sitting there. So it just seems so out of place. This bright red Dr. Pepper can sitting 3,000 or so meters below the ocean.
Yeah, exactly. It really makes you stop and think.
Yeah,
But also
absolutely.
these are like artifacts from like this other terrestrial world that these animals are seeing down there too. They've never seen a can before, and now there's a can for an octopus to kind of inspect. So, yeah.
Yeah. Okay. Question from a class in Toronto. Has the cord ever tangled?
Oh, okay. Yeah, so that's actually a big part of the job is making sure we don't entangle the tether. So for folks that aren't familiar with what we're talking about, at the back of the ROV, and sometimes from the top of the ROV, depending on the system, there's something called a tether. And so this is basically the high voltage that we send down to power the vehicle, the fiber optics that we're using to communicate goes through this long cable. So this cable is thousands of meters long. So to answer your question, has there been entanglements? Once, and that was a few years ago, and that was on some fishing gear. And so there is actually some fishing line that went like this in the water column, like about 100 meters up, and it actually entangled between the ship and the vehicle. So we don't have visibility there. And that was the only entanglement that I've been a part of. And that took a while to get out of because we had to kind of go inspect it and then work our way out. But usually, and we've done hundreds and hundreds of dives, we're really vigilant about line and about our own tether because we don't want to get entangled because that could be the thing that severs the vehicle from the ship. So yeah, there's something called a turn count. So if you ever hear someone refer to a turns, like I have to take out my turn, it means that we don't even want to spin the vehicle 360 because that could potentially create unwanted strain on the tether. So we always are mindful of how many rotations we've done with the vehicle. So we're really vigilant about it. But once I would say we've gotten caught.
Yeah.
And that was stressful.
I can imagine. I remember, well, two things come to mind. One, I remember on the first dive, we did come across a fishing net on the bottom, and it was kind of all hands. Everyone was like, okay, we're making this huge swing around. We're not getting anywhere near that thing.
Yeah.
And then, so we on the ship, on the Darwin 200, which is an expedition we're following with Exploring by the Seat of Your Pants, we have an ROV on board, but it's a small one. It's got a nice camera and lights, but it's pretty much handheld. And the cord, we have two tethers for it, one 100 meters and one 200 meters. And that is complicated enough to try and keep that from tangling and keeping track of that. So several kilometers of cable is, quite a next level undertaking.
Yeah. No, for sure. Also, I would say too, another thing that's happening behind the scenes with the tether. So there's two different types of systems. There's a single body system, so one ROV in the water, and then there's a kind of two body system. So there's a cable, a vehicle, and then a cable coming off the vehicle or a tether coming off the vehicle to the kind of one that we use for a lot of visuals. And so they're very different operations. But we're also always monitoring how the tether lays, is how we call it. So how it looks in the water, how it kind of floats up from the vehicle. And so we have these footballs, we call them. So syntactic foam, it floats in the water. And we put these on the tether at intervals in which we know exactly what that lay looks like. So we try to make this like giant S underwater. So that it's not dragging on the seafloor. And so it's up, but it's also not yanking on the vehicle. So we can still fly around and do some cool shots.
Yeah, very cool. Okay, one more question for you. This is from Miss Coburn's crew in Hamilton. They're heading towards high school. So they're wondering if you've got any insights on courses that could maybe lead students to a path like this.
Yeah. Oh, cool. Well, exciting that you're going on this next journey into high school. Um, yeah, there's a lot of programs even from when I was in high school. So MATE is a really good one. That one's all ROV focused, actually. And I think that one starts in high school, if not middle school. So MATE is definitely one to look out for. First Robotics is also a great one. So there's the First Lego League, First Robotics. I was actually a part of First when I was in high school. And that one's also a great way to just get familiar with ROVs with robotic systems. Also, any engineering class that you take are usually good ways to kind of get introduced to what is, robotics. And if you're interested in deep sea, but you know, you're not feeling the engineering space, that's all cool too, because we need people out here that are not just engineering minded, but also communications minded. So storytellers, we're really in need of people that can communicate what's going on out here. So really, it will take kind of a whole slew of different people and different interests and different skills. So the most direct answer is mate and first robotics and engineering courses, but also arts. We need more artsy people out here, and they help us create such really awesome visuals to communicate ocean sciences. Um, so yeah, if you're interested, there's also online exploration you can do. So we live broadcast all of our dives. So EV Nautilus has one, Schmidt Ocean has one, and also Okeanos as well. So look up live ROV dives and you can follow along. And also, sorry, one more. There's a game
Yeah.
that's being released by Embari. It's called FathomNet or Fathomverse, and it's basically you can help science for deep sea science by saying, helping annotate the dive footage, but in a way that's kind of a game. So there's a couple different resources, I suppose, and I'll pass them on to you, Joe, so that you can pass them out later.
Sounds good. All right. We are at that time where we're going to wrap things up for today's event. We've got another one coming up today at 2:00 Eastern. We'll be hanging out with Felipe. He's joining us from Colombia, and he's going to talk about the shark research he's doing, which will be pretty cool. Jess, a shout out to our classrooms for the great questions, for playing Kahoot with us. Always good to have you along with us, and a shout out to those tuning in later. Jess, thank you for letting us steal some time. I know it's a busy time as you prepare for your next expedition out in the field, but thanks for spending a little bit of time with us before then.
Awesome. Thank you. And thanks to all the classrooms, and happy Oceans Week, everyone.
All right. We're going to sign off for today, but we hope to see you in a few more ocean events before the end of the school year. Thanks, everyone. Thanks, Jess.
Thank you.
Okay, we're offline.